on Friday, we learned 3 things. Learning targets are on the board. We're doing chapter 3. What were the 3 things that we learned last week? Somebody give me one of them. What you got, Brent? With elimination. There you go. What was another one? By substitution and by graphing, right? So look at this one right here. You got Gloria and you got Sarita. So what way did they use graphing? No? Did they use substitution?
Yes.
They used elimination? Okay. So how did they get 3x from 6 and negative 3x? Did they add them or did they subtract them? They add 6 and negative 3 to get 3, or did they subtract 6 and negative 3? They added. All right. And so if I add, does that give me positive 3? Yeah. If I add the 4 and the negative 4, does that give me 0? Yeah. If I add 26 and negative 17, does that give me 9? Huh? Yes. Okay. If I divide, do I get 3?
Yes.
Okay. When I plug that in, and I get 18, is her y value correct?
Yes.
Yes? Okay. Well, then she's good to go so far. All right. What about Sarita? What did she do to get 3x? Add or subtract? All right. And then, all right, so what's 26 plus negative 17? It's supposed to be positive 9, and she got what? Negative 9. So, here we go. Who's correct? Gloria is correct. All right, because what did Sarita do?
Because Sarita added incorrectly.
Okay, so Sarita, hey, added 26 and negative 17. Thank you. Did we run out this time or no? No, sweet. Good. Yeah, we all write one and I'll sign it? Okay. Oh, where are we at? What can we say? Sarita added, I probably should put added, use correct grammar. Added 26 and 17. To get negative 9 instead of positive 9. Y'all okay with that?
Yeah.
Okay. Alrighty. Well then, what about number 14 then? Number 14. Okay, so you got x greater than 0. Guys, how do I graph x at 0? I put a dot where? Here. On 0. And then, what do I do from there? Make a line. What kind of line? A vertical. There you go. A vertical line. Perfect. Alright, and then it says x greater than. So where do your x's shade if they're getting greater than? To the right. There you go. Don't make it too terribly dark because you got 2 other ones you got to graph, okay?
Wait, if it's greater than 0, why are we?
Because it says x. X's go to the right.
No, but like, why aren't we stopping at 0?
We're not stopping at 0. We went all the x's that are this way.
Oh, just kidding. I meant the line.
Are you sure?
Yes.
Okay. All right, what about number 2? Y is greater than 2x. What's your y-intercept? 0. And your slope?
2
over 1. So we'll start at 0. We'll go up 2 and right 1. Or, because I told you not to shade too dark. And then, or you can go down 2 and left 1. Right, open dot, or open line, or closed line? Closed, there you go. Alright, now this one says y greater than. Your y's go up and down. So where are the y's going to get greater? To the top or to the bottom? To the top. Now don't shade too dark again because you still got one more you got to shade. But do you see where the shading is starting to overlap right there? Okay, because that's what we're going to be concerned with.
I guess we need to do this.
No, you don't have to. Alright, we got one more. And on Friday, we talked about 3 different ways to do graphing, substitution, and elimination. When we graph, what do we always have to look for? When you graph, guys, we have no idea how to graph.
X and Y.
When you graph, what has to happen? Thank you, Brent. I mean, come on, guys. So how do you get y by itself? You subtract 2x, so y is less than or equal to negative 2x plus 7. Now you need two letters to graph.
X and
No,
Y.
M and B. What's your y-intercept? And your slope? Negative 2 over 1, right? So we go up 7. Negative 2 over 1 tells me to do what? There you go, perfect.
I shaded mine on different levels, depending on the overlap. And basically, the more overlap, then it gets really
Sheet.
Alright, so from there, it says y less than. So your y's go up and down. And so where are your y's getting less than? Above that line or below that line? Below it. And it may be hard to see on your paper, but on my paper you can see that they cross right here at this little triangle. So you can make that a little darker. Make that a little darker right here. Okay, so we answered part A. It said to graph, right? We did that. Part B says determine the vertices. Guys, what's the word vertices mean?
That point.
The points where they all connect, right?
Right.
So this guy, ooh, that one's in the middle, and that guy, right? So what's this point right here? 0, 0. There you go.
Great.
All right. What about this guy right here? Because he's easy to do. 0, 7. Yep. All right. Now this guy is on a point. Like I'm not going to be able to type. Sir?
1.5, 3.5.
You have no idea if that's correct or not. You're guessing. So we can plug it in. We can plug it in, and we can figure out where it is. Now, besides graphing, there are two different ways that we use this. So let's figure out which two equations. Look at the yellow graph. Which one was the yellow graph?
2x plus y.
There you go.
Greater than or less
This guy right here. And then you got the green graph right here that hit at 0. Which one was that?
than 2x.
2x. So on Friday, we didn't do inequalities. So let's just talk about equations. So we had y equals 2x. And we have 2x plus y is equal to 7, right? On your paper? On your paper? As in, write that down. Because you're going to have a math workshop test next week.
Oh, for real?
Mm-hmm. Next week's last week of the quarter.
Oh, for real?
Mm-hmm. All right, so now, does that look more familiar to you like what we did on Friday?
Yeah.
Yeah? We have a letter by itself. And when we have a letter in general by itself, which one do we use? Graphing, elimination, or substitution? There you go. So we're going to plug this guy right there. So we have 2x plus 2x equals 7. 2x and 2x is 4x. Divide, and you get a fraction, right? Which we know we should get a fraction because it hit in a fraction. So we should get 7 over 4. So we at least know our x value is 7 over 4. Then we get to plug it back in and find our y value, right? Which one of these two guys is going to be the easiest to find my y? The top one, right? So I'm not going to do 2 times x. I'm going to do 2 times the x I found, 7 over 4.
How do you do fractions in there,
So I get 2 over 1. I'm going to use my brain. I get 14 over 4, right? Then that will reduce. What's that reduce to? 7 over 2. Very good. So that'd be 7 over 2. Very nice. Very nice. Y'all okay? All right. Here we go. We got a lot of review to do today. So then we're going to review our ACT that we did Friday, 15 and 16. So go ahead and grab those real quick. If you do not have them because you were out last week, they're on the table over there still for you. So go grab one real quick if you need one. Well, we're going to go over that too. This page, whatever that next one is, page 4. All right, so when we do the ACT, we are not concerned about reading the entire thing. The only thing we're concerned about is reading the actual question first, because most of the time we can get by with answering that. So what is just the question asking us?
In the figure below, all of the same squares are equal in area, and the area of the rectangle.
Just the question.
That is the question.
No, that's not what's asking you. That's a statement. The question is where the question mark is. There you go. Just this part right here. Because this is a small one, though, but there's several of them that are like a book, and you're going to waste time reading. So what are the two things that are important out of that? Uh-huh. All right, so you're going to have to find two different areas. First of all, what is area? Base times height, length times width, same thing, right? Okay. Then I need to find the area of the shaded part, which is the same thing. What you got, Brent? Okay, when we get finished with this, we'll see what's going on, okay? The only email I have is about volleyball players. Volleyball. Let me see it. Alright, so Noah, how many blocks make up the entire length of this? Not shaded, the whole entire thing.
Well, let me count.
Count and see, please.
1, 2, 3, 4, 5, 6, 7, 8.
8?
I have 8 on the bottom.
Alright, very good. Isaiah, how many?
Golly,
Why do I keep calling Isaiah? Isaac.
Yes.
Okay. Isaac, how many? Do y'all see why my patience is so thin this week?
Yeah.
Plus, I haven't gotten very much sleep. You ready? Yep. Alright. So, what about the width? Isaac, how many boxes make up the width of that entire thing? How many? I can't hear you. Well, Noah did this way. So you're going to go down. Yes. How many? Emily, now we need to do the shaded region. So how many shaded boxes are there? Ma'am? This way. Evan? Elizabeth. Now I need to find out what the width is. So how many? 5? So they're comparing your lengths and then they're comparing your widths. So Nate, can you tell me what my two lengths are up there? 8 and 7, perfect. So Kaylee, which answer choices do not have 8 and 7 compared? That do not. Yes, ma'am. Just A and B, right? All right. Then Aaron, they are comparing your width. Aaron Unger, they're comparing your widths. So what are the two widths in that in our problem? The 6 and the 5. Perfect. So Kayla, can you tell me which ones compare my lengths of 7 and 8 and my widths of 5 and 6? E. Perfect. Y'all okay? There was one like that on the ACT for September, by the way, because I get bored and I have nothing else to do but walk around and work out problems in my head. So there you go. I have nothing else to do for an hour. So. Well, if they leave it there for a minute, then yes, I can. If they kind of flip over real fast, then I can't.
Isn't that like good people?
No.
She just can't tell you the answer.
I'm not giving you the answers. I'm not writing them down.
If you could take the ACT right now, what would you think?
A 0. Here we go. 48. They give you 48 right here, and they tell you that AB is congruent to AC, right? Y'all okay with that?
Yeah.
And they want you to find out what the measure of C is. So from geometry, they told you a theorem, and if they had these two sides were the same, there you go. And so in math, if we don't know what something is equal to, we can call it something. What do we call it? X. Very good, Sam. So a triangle adds to be how much?
160.
Ooh, 180. There you go.
Kidding.
So, Kirsten, what can I do first in order to solve that for X? You have two options. You could subtract the 48, yep. And if I do that, Ethan, what is 180 minus 48?
32.
Ethan. Perfect. Very good. Sawyer, what else could I do? Add what? Which gives you? Perfect. All right, let's see. Jennifer, if I get 2x equals 132, what can I do from there? All right, what do I get? Perfect. So my answer is J. Y'all okay? All right, so we need to go over your homework from Friday. Your homework from Friday was 4, 5, 6, and 7. So grab that real quick. All right. If you weren't here Friday, then you're going to get the answers, but I'm not going to show you how to do them. So, number 4, you should have gotten 3 and -1. All right. Do you have any issues?
I got like a super weird.
I'll be with you in a minute. All right, number 5. Number 5, you should have gotten something to the effect of 0 equals 0. If they equal each other on two sides, then what does that mean? All row numbers. Very good.
I was on the wrong thing. I didn't get that.
You didn't get that?
Yeah, I
Perfect.
was on the wrong thing.
Oh, you're on the wrong page. Okay. All right. If you got them wrong, fix your answer real quick, and then I'll come by and help you when we're doing our independent stuff today, because we're going to work in groups. All right. What about, let's see, number 6, you should have gotten -1 and 4. Anybody have any big issues with that one? Anybody I need to come see and help with number 6? All row numbers. So everybody's good so far?
Yes, ma'am.
For those of us that actually did it. And number 7 should be 4. Sir? Who says I was talking to you? Goodness, guilty conscience? Guilty conscience. Goodness. What is this?
I didn't do it.
So, number 7 should have 4 -1. Does anybody have any issues about number 7?
I took that one, and I forgot what it was.
I was here all weekend.
You a lie? Don't even lie to me. 7. You came for like 30 minutes and helped Sunday.
I hope for at least an hour.
Okay, I'll give you an hour. 7. Do we have any issues with 7? Does that need to come around and help anybody with 7? Going once? Going twice? 7? Okay. Alright, so here's what we're going to do. So, Kaylee, I'm going to see you in just a minute, okay? Alright, we're going to skip all these word problems for right now, and we're going to review what we did on Friday, and then we have a checkpoint. We have a checkpoint today, and then we will have a quiz on this stuff on Wednesday. Are you sure?
Yeah.
Positive? Was it a sign or something, or something?
It was I subtracted.
Oh, okay. See, try it again and see if you get the right answer, okay? All right, so we're gonna do this in groups. But before we get in groups, we're gonna make sure we're all okay. Number 1 and 2 says to solve by graphing. So if you have your notes, flip back real quick and look at our little notes that we made about graphing. What are we looking for before we can graph? Something has to happen to those equations first. Has to be solved for what? For y. So 1 and 2 has to be solved for y because you're graphing, okay? Has to be solved for y. You might want to make yourself a note of that, especially if you weren't here Friday. Has to solve for y. All right. Hopefully you made yourself a note of that. If not, you better do it quickly.
I sure did.
This quarter is over next week.
Oh, gee.
All right, here we go. Next one, number 3, says substitution. So look back at your notes real quick. What did we do with substitution? Huh? Yes, but what do we have to look for?
A single letter by itself.
It doesn't matter, right?
Right.
Just X or Y. Doesn't matter which one. Do you see a letter that is going to be extremely easy to get by itself?
Yes, ma'am.
Which one?
Why?
Which one?
Why?
Top one. There you go. Which equation I should have said. I'm sorry. So the top one's going to be very easy to solve for Y, right? And then putt-putt, you would insert it into the other one, right? All right, number 4. Forces elimination. What do we look for with that? Same number with the same letter. Look at the X. Ooh, here we go. Look at the X's. That one has 3. That one has 1. Are they the same number?
No, ma'am.
Nope. That one has 8. That one has -1. Are they the same number?
No, ma'am.
Nope. This one has 1. This one has -3. Not the same. -1, 3. Not the same. So you have to make them the same By doing what?
Multiply.
Multiplying by whatever number makes them the same. Y'all okay? Alright, last ones down here at the bottom. 6 and 7. You have to choose what's the best method. You either have to choose substitution or elimination. Substitution means you got to have what by itself?
Hey.
A letter, right? And then elimination means that you have to get numbers and a letter the same, right? Y'all okay?
So you can do either form. Number 6 and 7.
6 and 7 says use the best method. Whichever one is correct. Whatever method is the easiest. Okay? Alright, find your partner. We're going to put the answers on the board as we go. And we're going to work these out together. Find your partner, go.
You gotta go over here this time.
Alright, Noah put up number 1 for us. Let's talk about our answer real quick on number 1. Your answer is where they cross. What is this point right here where they cross? -3, -3. Very good. There were 3 different graphs. One where they crossed, one where they were parallel, and one where they were the same line, right? Do you remember what they were all called? Consistent, inconsistent, independent, dependent. Which one's this one? Very good. Consistent and independent. Very good. And this one, the parallel is inconsistent. And just to make sure we're okay, if they were the same line, what do we call those? Consistent and I so just spelled that wrong. Consistent. There we go. Consistent and dependent. There you go. Are y'all okay? Does this bring back some memories from Friday? All right. And then Aaron's going to come up here and do number 3 for us. All right. Let's check our work on 3. Check our work on 3. -110. Good to go? Oh, you good? Yes. Okay. All right. 4 and 5 says you used elimination. All right. There's 4. Should have gotten 12, -3. Are y'all okay on that? All right, Jesse, do you have number 5, buddy? You want to come put it up for us? What? Hold on. Where do you get a 12 at? Positive. Oh, you added it over instead of subtracted. That's it. There should be a 6. There we go. There we go. All right. Hold on. All right. So number 5, you should have got no solution. Y'all okay on that? Because 0 does not equal 15. Those are not the same thing. And then number 6. So Jesse put up number 5 for you. Madeline put up number 6 for you. She got 9, 7, and she is correct. Are y'all okay? Any issues? All right, Putt, do you have number? What's the last one? 7. Perfect. Put that up for us. All right, and then Putt's going to come up and put number 7. Number 7, you should have got -6 and 5. Are there any issues? 6. Y'all, this week, for real, you're going to have to keep me straight because I'm running on a little sleep, okay? 6 and -5. Are y'all okay? All right, we have about 2 minutes. We're going to start a checkpoint. Start. So go ahead and slide your desk back over.
Oh, you said star.